Now we're going to learn how to write our own functions. So to do this, we're going to open a session. All right, and create a Python file. Now you're going to learn two new keywords right here. One is deaf. The English meaning of deaf is to define. And you'll see why the to is in there. And now you can do this. We're going to give the name of a function. We're going to call this one, let's give it a more descriptive name. You can give it any good variable name, it's just fine. Same rules as variable names. In fact, function names are variable names. And you will see that this is a form of assignment. And this is about as complete a sentence as x equals, and then nothing. Okay? So, to define the square of x, we see keyword number one, deaf, because it turned that brownish color. We're going to say return x star x. Okay, we just made a function. Now, if I run this program, let's run this program right now. You think nothing has happened. That is not true. In fact, allow me to convince you. Let's do this. Print dir. Dir will tell me all of the visible symbols. Remember, we talked about symbol tables. All of the visible symbols that are present. And if I go ahead and bail out of here and run this again, you'll see all of Python's linguistic infrastructure. That's all that double underscore stuff. And then at the end here, you see square. Square is just another variable name. We have created a function called square. Now, why didn't anything happen? Because we didn't do anything with it. Once you make a function, you need to invoke it or call it. That's what we call. When we use a function, we say we're calling the function. Here, let's have a little format string exercise here. I'm going to get rid of the print dir because it's now we know what it does. It reads that function into memory. That function has been read into memory, and then we didn't do anything with it. But we could do something like this. Print. Print is a function. It's part of Python's infrastructure. It's in all those double underscore things. So now we're going to go ahead and say F for format string. Let's make a variable on the previous line. Why don't we? I'm going to do this. And I'm even going to do something that's going to surprise you. I'm going to use that same name x. Okay. So now I'm going to say f of x is equal to f of x. All right. Now, what's happening inside of here is x will be evaluated. It's 6, so a 6 will get dropped in there. And then here, f of x will be evaluated. So what's going to happen is this 6 is going to come up here. Python's going to say return 6 times 6, so that's the output, and the output gets dropped into here. So let's take a look at that. Okay, so now we're going to go ahead and come out. Oops, I used the word F instead of square, and I got appropriately burnt. Okay, let us remember what we're doing. Originally, I was going to call it F. And then I got the bright idea to think of this as being a more descriptive name. Now let's try that again. And it'll probably make more sense to you. Maybe that didn't make sense before. There, look at that. F of square of 6 is 36. So here's how the program executed. Let's talk about that. This function got read into memory. A function is a Python object just like anything else. And this name square points at some location in memory where the instructions necessary for that code to run are stored. So a function remembers a procedure. The procedure it's remembering here is output the square. Then I now am defining a variable called x, and I'm setting it equal to 6. And you're going to see that it's okay that there's no conflict here, because there's a rule that says what happens in Vegas stays in Vegas. If you make a variable like this inside of a function's what's called its argument list, it's not seen outside of the function. So like there's no more x anymore. Now we have a different x. That x belongs to the main part of my program. And here I'm printing f of 6 is equal to f of 6. And f of 6 is 36. So we get f of 6 is 36. And that's how you define a function. Question you might ask is this a mathematical function? Well, let's think about it for a moment. It takes a number, and any time it takes that number, it returns the square of that number. And that is a consistent action. You're not going to get different things happening different times. And so as a result, we have a mathematical function here for computing a square. Here, let's make another function called cube. Now I'm going to do something a little interesting here. I'm going to say, hey, this is kind of like volleyball. How does volleyball work? The ball comes over the net, and usually a player who's called a setter will deliver that ball to somebody who's near the net who'll spike it. So there's teamwork going on here. Is teamwork allowed with functions? Yes, it's allowed with functions. So functions, these two functions that are directly in the file can call one another. This function cube calls the squaring function. Now being doubting Thomases, let's go ahead and do this. And let's see if this happens to work. All right. Let's see if we're satisfied customers. Yes. I happen to know that 36 times 6 is 216, and that all is copacetic, and this is working just fine. Okay? So these two functions here are plain old mathematical functions. Now, I'll show you another example of a function that is not a mathematical function. I'm going to say print, and then I'm going to use a triple quoted string. Deal each player. Deal all the cards. To the players, and I can come all the way back here. You'll notice, by the way, that things inside of functions are indented. That's called the functions block. Okay, so deal all the cards in the deck to the players, and play proceeds as follows, etc. All right, and I'm using a triple quoted string here just for fun, so you can see it at work. Okay, print all that. Now, to invoke or call game rules, I just go like this. You might ask, why didn't I say print game rules? Why did I just say game rules? Because what happens when I call this function, control of the program passes up here, this print statement executes, and then the function runs out of code. This function has what's called a tacit return. A tacit return means function runs out of code, it returns, and you'll never guess what it returns. But we'll find out in a minute. let's go ahead and see that this actually works. Okay, there it is. It's working. And let's go back in here and let's say print game rules. And let's see what happens. This program's still going to run, but it's going to have this annoying effect of printing a none because the output of the print statement is none. So you asked it to print that output, and it did it. Okay, so this is a function. This function down here, these functions are mathematical functions. This function is pure side effect. What does it do? It puts text to standard output, which for people who are Unix savvy, you know, standard output is just another file. So it's putting text into a file. That's a side effect. And when the program is over, you know how you can tell something's a side effect? When the program is done running, you can see evidence of what it did. In this case, it printed text to the screen. Okay, so this, in fact, there's all kinds of side effects going on down here, but these functions themselves don't have side effects. Now let's have a little grammar lesson here. Okay, just so we know what the proper terminology is. This thing is called a function header. It is a boss statement. And remember, something's down here. Let's make some comments down here. You read this as to define. That is a subordinating clause, and therefore it is not a complete sentence. Okay, so this is grammatically incomplete. Incomplete. And therefore, it's a boss statement. One feature of boss statements, they have two features. One, they have a colon at the end. Omit the colon, and Python will hiss at you. And the other feature they have, they own a block of code. That's why they're called boss statements, because they control a block of code. That block of code could even contain boss statements and often will. But it will contain at least one worker statement. You can't just say def cube of x and leave it hanging, because Python's going to say that's an incomplete sentence, and it's going to sit down and have a hissy fit, and it's going to stop right there. Your program is going to fail on the spot. Watch this. I'm going to take away somebody's colon and see what happens. Goodbye, colon. All right, let's see what happens. Python fun.py. Uh-oh. Line 3, invalid syntax. Well, if I go to line 3, colon 3, using my handy dandy Vim editor, I can see there's a missing colon, and I better put it, okay? So a boss statement is a grammatically incomplete sentence, and it contains, or it owns a block of code. And by block, I mean a sequence of indented statements, okay? This is, right here, this is Square's block. Okay, this is the block belonging to Square. Okay, a block can consist, it has to have at least one line of code in it. It can have many lines of code in it. If you want to stub in a function, just for future use, this is legal. Okay, and I can pass whatever arguments I want there. The things inside the parentheses are called arguments. And this will do two things. One, it'll run. And two, if you call it, it will return the default value null. Pass just means do nothing. To define unsure, do nothing. Complete sentence, right? So what happens is the block of code completes the grammatical sentence. Python only understands complete sentences. So you have to think that way. So that is your first introduction to functions. We are able to create a function by using the def keyword. In the next video, what I'm going to talk about is an issue called scope. Scope tells you what is visible and what is not. And you might think, oh, it's great to have everything visible at all times. It's about as great to have that as it is to be stuck on the Long Island Expressway with a full bladder. You don't want to be in heavy traffic. Heavy traffic is a problem. So we will talk about scope next time.